What if I told you you could actually teach a robot to make decisions? No ChatGPT, no autopilot needed, just logic, sensors, and pure coding fun. Welcome back to Cyber Wizard, where we make coding easy. If you already seen part 1 and 2, then you know how to navigate the Eclipse IDE, get into a coding space known as a class. Also the language of computers, variables, and syntax. Today is part 3, teaching a robot how to think, using a sprinkle of Python while translating the logic from block code to Java. Taking advantage of this scenario, showcase if-else statements while playing with a virtual robot. Alright, let's go. I want to start by showing this cool website called Vex VR. You should really check them out. They have a variety of free maps where you can use simple coding blocks to help the virtual robot maneuver the map. This robot is all ready to go, and the map that is set up is Dynamic Castle Crasher. As you can see, right here in the bottom right, you can change the view of the robot from third person, which is what I like, or first person, even bird's view. To run the code, which I already assembled through the blocks, just hit play. What's going on here is the virtual robot is thinking, making decisions based on the code blocks working in the background, looking for castles to crash while attempting to stay on the map. Don't worry though, the website comes with follow along courses to walk through building the code from scratch. This map is fun to learn because it has no walls like some of the other maps. Each time you restart the map also changes. Logic is the foundation of programming, and a good example of how computers and robots make decisions. I want to use this Vex VR to show if else statements in action instead of just giving a boring lecture. Understand coding in the beginning is very technical, and you should not avoid learning the fundamentals. Seeing a robot perform your code, though, is pretty exciting and gives you insight into the world of programming, mixed with robotics. There are many paths to take when learning to code. Don't forget, the possibilities are endless. Always try to use your imagination and software skills to work on projects you like. I want to revisit the Eclipse IDE I had open to show a quick demonstration of if-else statements I wrote up using an integer variable named age as our basis for logic, setting it equal to 21. This is the first half of the do while statement. If you click at the beginning of the curly braces, you can see where the do statement ends and the second of the do while statement begins. Inside the curly braces for the do while loop is the first if else statement. Next to the statement, we have the condition. If the age is greater or equal to 18, then perform what is in the curly braces, which is print out you can vote into the console. Else, the console will display you cannot vote. If you're a beginner, you might have noticed when you click on a word, everywhere it is used also highlights. Also, you could change the color like I did to be more aesthetic and easier to follow along. Here's another variable. This time it's a boolean named hasId, which can be true or false. Underneath, another if-else statement using our two variables age and hasId. The condition is inside the parentheses. Two ampersands means to perform if the first and the second condition are true. The action performed would be printing out you can enter the bar into the console. Otherwise, also known as else, prints out access denied. The age minus minus means subtract 1 to the variable age every time this point is reached. At the same time, I want to visually keep track of the age. Finally, we made it to the second half of the do while loop, which is age does not equal 16. Perform the sequence above. Alright, let's run it and see how it plays out. You can see the first iteration of loop here where the age is 21. It says you can vote and enter the bar. The next iteration prints out 20 and demonstrates you can vote, but try to enter the bar gives you access denied all the way down to age 16, where it prints out at least you can get your driver's license. This is our robot's brain right now, constructed through the variety of blocks on the left. When start is kind of like our main method in Java, telling the code to start here. Comment blocks are good practice to help understand the process of your code. The comment blocks are closer to the bottom of the logic block list. Here I just wrote a quick note saying how changing the speed can affect the sensor problem I was running into during my trial runs. Feel free to adjust to your own liking. Next, let's cover a little bit about logic surrounding this block code. This forever block keeps the code running endlessly. When you click on the block, it highlights. You can see the entirety of the block and the nested code inside the forever loop. I added another comment block here to remind myself the robot repeatedly is looking for castles to knock down during this part of the code. This nested repeat until loop has the condition if the down eye or the bottom sensor detects red, then break out of the loop, reverse 30 millimeters before turning left 110 degrees until it breaks out of the repeated loop. Then it will perform this nested if else statement. The if else statement basically says if there is an object detected, then drive towards it, else turn left. You can also pick turn right in this scenario without negative effect on the performance or the outcome of the map. I put 300 and 110 degrees, but you can change it to whatever you want or what works best. And like I said, here on the left are the variety of blocks you can use to maneuver the variety of maps. Moving on to the sprinkle of Python. You can click here on Code Viewer to see the Python code compiled for the blocks. You can also perform the map with Python instead of blocks. Now let's remove the training wheels. Behind every block is actual Python code. As I open up the Python code, I see a couple things I want to go over. For example, this when started is like the main method in Java, telling the code to begin here. This global my variable is close enough to the public static void. Here you can see where I left the comment block. In Python, you start a comment with the hashtag. In Java, you start a comment by putting two forward slashes. The first few lines set up the robot speed and direction. Drivetrain is the object created here. Set drive velocity and set turn velocity are methods used by the object. Then comes the logic. While true is the forever loop. Nested inside is this while not, which would look different in Java. However, the logic's still there. While this condition is not met, perform this nested if-else statement. Otherwise, break out of the loop. Reverse when red line is detected. I also want to take this time to show what a runtime error would look like in Python. When it was block code, it didn't really matter that this break was here. However, if you try to run it, you'll get an error. It even tells you what line to find it on. But if you remove this line, the runtime error disappears and the robot performs just fine. So today was a big step forward from part 1 and 2. You didn't just watch a robot move, you watched it think. How to teach it to make decisions using logic. The same foundation behind AI, games, robotics, and software. If this helped you see code differently, smash the like, subscribe, and drop a comment. Do you prefer the videos in Java, Python, or block code? What topics should we explore next? I was thinking graphical user interface, also known as GUIs. Otherwise, I could revisit more fundamentals. Stay curious, stay focused. This is Cyber Wizard signing off.